Hello, everyone, and welcome to the Stellar Open Protocol discussion. So in these meetings, we discuss core advancement proposals, aka CAPs. These are technical specs that suggest changes to the Stellar protocol necessary to allow the protocol to continue to evolve to meet the needs of the ecosystem. And we live stream these meetings so that anyone who's interested in watching they can follow along. Although I do want to note it is a technical discussion. So if you are watching, you may want to take a look at the CAPs themselves, and they're linked to in the show description. Also, we do keep an eye on the discussion box, and your comments there, they do help us inform our decisions going forward. Today's discussion will focus on two CAPs, and our goal is really, as it is generally in these meetings, to try to resolve some outstanding questions about them. So we may not address questions that you ask directly, but if some relevant ones come in, I may actually try to incorporate them into the conversation. So as I said, we are focusing on CAPs, and this meeting is just part of the CAP lifecycle. So generally, CAPs are discussed on the Stellar Dev mailing list. There's a link to that mailing list in the event description for anyone who's interested in joining the discussion. Then CAPs are drafted and iterated on based on feedback and suggestions, and they end up here in this protocol meeting. And based on what happens in this meeting, they may be put up for a vote by the CAP committee, who decides whether or not to accept or reject a CAP, which point they move into final comment period. So everyone has a last chance to raise questions on the Stellar Dev mailing list. And if it makes it through final comment period, a CAP is implemented into a major Stellar core release. And then there's still one final step, which is that every major release, every protocol upgrade is voted on by the validators and has to be accepted before it's applied to the network. And so all of that is to say this is a long process where there's a lot of public participation, and ultimately the network decides to accept major protocol changes. So enough preamble. Today, we are discussing CAP 21 and CAP 40. Both of these lay the groundwork for building payment channels on Stellar. So payment channels, they allow multiple parties to securely transact off-chain and periodically settle on-chain. And among other things, they could make it easier to build high-volume use cases on Stellar. So if today's discussion seems dense at any point, keep that in mind. These CAPs make technical changes geared towards payment channels, and payment channels are important for scaling network throughput. So without further ado, we will look at the actual CAPs. We're going to start by talking about CAP 21. This proposal generalizes the time balance field in transaction to support other conditions, including conditions that relax sequence number checking and provide relative time locks. Since we last discussed this, there were some small technical changes. There was also the addition of extra signers, and I think we should start there. The new precondition extra signers has been added. Lee, can you just explain what why that addition happened, and sort of talk us through any questions that you have about
it? Yes, so extra signers was initially added to support stateless HTLCs. So the ability to say that this transaction needs to be signed by, or a hash needs to be included with this transaction to make it valid. Without having to store that hash as a signer on the account. So right now you can use the #X signer to say that you need a hash included with transactions to be able to transact with an account. And instead of needing to store that on the account, it can now just be stored within the transaction. And then second, it's also being used for CAP 40, which we'll talk about later.
Would it help for me to overview the other changes to CAP 21? Just because, I think it was already people were kind of generally okay with it the last time we discussed it. And so a lot of these changes are kind of in response to Lee's specific implementation experience, things that just came up because of implementing it.
I think that would be super helpful. Yeah.
Great. So yeah. So one of the changes is that the previous version didn't really talk about the results, and there's new failure modes now because you've got these multiple preconditions, and so you might have sort of multiple preconditions failing. And in particular, you could have preconditions failing because it's too early, or preconditions failing because it's too late, or both. And so what we basically said is if a transaction can never be valid again, then even if there's other things that are too early, we'll still call it too late. And we'll give the result code TX too early only in the case that there is the possibility that the transaction can be valid again if resubmitted at some later time. So basically, if you have a thing that's too early and a thing that's too late, that gets combined to a too late error. And so that fits it into the existing error codes. And I think, preserves the sort of the intuition that if you're too late, you can never resubmit, and if you're too early, there might be a chance of resubmitting at some later point. So other things that we changed, there's some clarifications. Oh yeah, we kind of rearranged the stuff that's dangling off the account entry in the ledger, because it turns out that the sponsorship information is only there if you're actually sponsoring things, and so otherwise it's currently null, or it's a V1 extension instead of V2. So we changed that into a pointer, and we just kept the V2 data structure as a thing that dangles off the V3 now, optionally, if you're actually using it. And then the final change is that we didn't talk about, we previously hadn't mentioned what to do to an account that didn't have an account entry extension V3. And so the answer was just, now we just say, pretend all the fields are 0, right? So that means like, it's as if like the last time it was the last ledger where it was modified in time and stuff are 0. And that's okay, because even though that means anything that's like a relative delay will execute, anytime you would use these things, it would be on some new account in some new protocol, and so therefore there would be some other transaction on the account, and that 0 wouldn't matter. So again, it's just to be precise. I don't think it really matters, but it's important to like say that it's something, just to make sure everything is deterministic and fully specified. So I think that's pretty much all we needed to change, right? Did I forget anything, Lee?
No, I think that was everything that we listed. And I think specifically to do with the extension, like I'm really interested to hear what Nico, Siddharth, John, what you folks think of this and how this might impact core.
Well, the first thing I'll say is you were the one who kind of just prototyped out this implementation. So what was your experience doing it?
So I haven't tried the new change. So the difficulty that I definitely hit with the initial proposal was that there are assumptions made in core that the V2 extension is only present when the account's involved in sponsorship, and that shows up a lot in the tests more than in the actual application code. So I guess if core makes that assumption in tests, are there any other products or anything else that makes that assumption that might be interpreting XDR comes to mind?
I think. Please continue.
I think the new proposal, which says that the V2 is still only there when there's sponsorship, I think that works from my perspective.
From my perspective here, like, I don't think it really matters that much. I don't think it's really worth fighting about much, honestly, in the grand scheme of things. Like, I could see some merits to this now that we have all these dangling things. Maybe it would be nice to every once in a while, smush them all down into one single dangling thing, then dangle some more stuff off of it for a while and then smush them all down again at a later date again. I could see merit to that. I think in terms of like how core treats these things, core basically, like, the process that we've used for upgrading these extensions is basically like, there's like 2 parts to it. Like, one thing is like, once it comes into existence, we'll never unwind that. So like, if you sponsor an account and then remove the sponsorship, you'll still have the V2 extension. So the tests, most of them have these assumptions about when will these things appear, and that's what you were running into, not about whether they will be there or not, period. The other thing is that we already kind of made this executive decision when we added the sponsorship stuff that, like, imagine that you didn't have any native liabilities, so you shouldn't have had a V1 extension, but then you participated in the sponsorship. Now you have a V2 extension, and we just said, like, okay, well, in that case, we'll just inject the V1 extension and set it to 0. And it's no different from the case where you had added liabilities and then subsequently removed them. So from my perspective, like, core is designed in such a way that, like, either solution is completely reasonable. I think, like, in terms of the total net implementation changes, it would probably be less if we dangled it, but the size of the extension would be less if we didn't. So like,
so just to be clear, you're okay with the current state. So the current state is like a hybrid, right? Where V3 includes V1, but dangles off V2. So that's kind of, there's basically this thing called sponsor info that is a pointer to an account extension V2, but that's inside the account entry extension V3.
yeah, that would be fine. I mean, again, like it doesn't really matter, but like if you're going to do that, then the marginal additional cost of dangling the V3 extension off the V2 extension is even smaller because the 4 extra bytes are appearing in either case.
So you're saying that there's no situation where it's important that the V2 be null.
Correct.
Okay, so, well, anyway, I guess I don't care. What I really want is for CAP 21 to make it in. So like, what's the best structure to like make this happen, or is the current one okay?
I mean, I think it's I'm the one that always brings this back up. As soon as the current proposal in a way is kind of this weird hybrid thing, like that is neither the nested one, neither the fully like represented one. So I would say like either we consider one or the other, but not this kind of half broken one, because you get basically like the reason why you want nesting in the first place. That's kind of the whole rationale that we have in the repo actually on why we are doing nesting, is because it makes it easier for people to they don't have to change their code, right? Like if you depend on let's say sponsorship, you keep referring to sponsorship the same way. You don't have to add the conditions like, oh, if it's a V3, I need to go look for sponsorship over there instead of over here, right?
And so it's never going to be useful to take something that has sponsorship info and then delete the sponsorship info, or to kind of create new accounts that just don't have any sponsorship info because they've never sponsored anything. That's the question. It sounded like Lee kind of wanted this in order to make a lot of the tests easier to port.
Well,
they're not going to be easier.
Hold on, wait. Let me clarify something there. The V3 extension will always exist for a newly created account, right?
That's right. But the sponsorship info might not. Whereas so it sounded like currently there's like in a lot of tests, there's like accounts that don't have sponsorship info and that they never get upgraded to V2. And that, I don't know, that this is somehow, I don't know, Lee, do you want to, I did this primarily in response to your feedback, Lee. So I don't know if you want to jump in and.
Yeah, so there's two. So I think so far we've only really talked about the impact on core, and it sounded like from what John was saying, like there's not really a big impact on core. And I think the concern that I had around the impact on tests is maybe misplaced. But the second impact is the impact on the ecosystem, which I think is what Nico was highlighting too. And that is, everyone who passes this XDR will need to look for fields in the V1 and the V2 in 2 places. They'll need to look for it either in the V1 or V2 or in the V3 if we move it. And I think that's maybe something that Eric or like the Horizon team, that's something that they would be having to deal with. Basically, anyone who parses the XDR has to know to look for it in all these different places, which can also be a little bit of a foot gun for people who are upgrading because they may not realize that this field has been duplicated into a new place.
So, yeah, although we can mechanically fix it with like any place that gets translated to JSON, for example, we can just mechanically always move the sponsorship info out.
Yeah, I don't think we should be making any decisions based on the effect of downstream applications consuming ledger entries. Realistically, we're talking about 1, maybe 2 consumers. So we can talk to them.
Okay, so I think that to my mind, the 2 things that make the most sense are to either keep the CAP 21 draft exactly as is, or to flatten out the sponsorship info the way it was in the previous revision of the draft. So it's just all one big like V3 structure.
Wait, while you're saying that, so I'm looking at the current master. Is that what you call the latest draft? Because this one is the hybrid one that has like this half flattened version.
Exactly. And so I'm saying either we should just keep that, or we should fully flatten it. Just like instead of having.
No, but so no, but like, that's actually the one that doesn't make sense. The one that's half flattened. Either you're doing nesting, fully nested, right, where you extend V3 inside V2.
Okay.
Or you're doing the full flattening.
Okay.
And
so
then,
let's do that. How about the full flattening? How about I just, instead of making that up, instead of having sponsor info be a pointer to like an account entry or account extension V2, how about I just take the fields of account entry V2 and put them inline inside the account entry V3, or just put the whole V2 structure in there?
I don't really care, honestly. Flatten it or fully nest it, but yeah, the hybrid thing I think is kind of like the worst of all the worlds.
So I propose that I propose to just basically revert to what it was before, if Lee is okay with that.
What was it before?
Nested. It was nested before.
No, it was flattened before. It was just the fields. The fields of the V1 and V2 structures were just inside the V3 structure.
The thing is that I do think that every time we flatten structures, it involves changes in a bunch of places that we may or may not understand, and I'd rather not do it if we can avoid it.
So are you advocating for the nested version?
Fully nested is kind of as a default is safe.
Because you don't definitely require the fewest changes to core, because we already have a lot of
not just core, but like
nesting.
Yeah, it's not just core. It's also like anything out there that is actually using like looking up sponsorship, let's say.
So what about having them not as pointers, but just putting the V1 and V2 structures into V3? So then any XDR library can just kind of extract those things by type.
No, but it's the same problem. You have to switch. Like you have to change your code that still compiles and still looks like it's working, but it will just fail miserably when you actually run into that. Like existing code, it's always the same problem. Like kind of like the problem we created with the what was it, the Mux accounts, right? Like.
But I would argue that like Mux accounts is precisely because
it's way worse. Mux account was way worse because of course people use accounts a lot more, right?
Yeah.
But here we make it even more fringe. So that's kind of why, if you're looking at like the edge case of the edge case and you hope that people are going to do the right thing, I think it's actually less likely, because
I mean, the problem is that the nested is just like much harder to program to, right? It's like you're literally like fighting with like the right-hand margin of your text editor all the time, or it's like you have to put like line breaks in the middle of like expressions that contain dots and arrows to access fields. So it's just like, we're getting to the point that we're going to access fields that are like 4 or 5 or 6 deep in structures. It's just kind of like painful for the programmers. So like, yes, there might be like a little bit more stuff to do in transition, although I would argue that actually if like we do our XDR stuff right, it's actually not that hard because you can automate a lot of this stuff. And so I'd rather just have a little bit of pain up front and just have something that's like much nicer to program to in the long run.
So when I wrote the prototype, I actually used the nested version. I didn't use the flattened version because it was easier to do it nested.
You mean you put the account entry V3? You didn't use this XDR. You put the account entry V3 inside the account entry V2.
Yeah, I'm pretty sure that's what I did, and it wasn't that bad.
How wide? What's the width of your text editor?
I mean, I used soft wrap, word wrap. So
the thing is that, David, like if you want to have a helper function to avoid typing all this stuff, you can, right? Like that helper function is optional in the nested world. It's mandatory in the non-nested world.
And we already have all this.
Okay, whatever. I'm overruled. Like,
no, but that's kind of
you guys are all wrong, but I'll do it this way. I'll rewrite the CAP to do this.
Hey,
generations of like poor Stellar programmers are going to have to be typing structures 6 nested deep because like whatever, you guys are worried about a non-existent problem. But fine, it's more important to get CAP 21 accepted. So fine.
It sounds like a reasonable concession. There we are, going with the nested version in order to get CAP 21 done. I like it.
I think this raises interesting points, though, for the preconditions type that we're introducing, because the precondition type is setting itself up to be like a flattened version, or at least that was my understanding of the proposal.
It would definitely work better. I mean, like in the like five years from now, there'll be no benefit. You know, there will be only disadvantages to doing what we're doing now. But like, yes, in the short run, it will be slightly smoother to do it with like a fully nested thing. It's just how when they were choosing, you know, not to fix the precedence of the bitwise and or operators when they went from BCPL to C and introduced like the logical double and double or, and they're like, well, you know, yeah, this is broken, but there's like hundreds of C programmers in the world. Like we don't want to, you know, break backwards compatibility. And, you know, then we got to the point that even Java adopted those broken
let's get back
precedences.
I don't know. I understand what you're saying, but at the same time, there is this need to sort of get something out there that people can adopt and start using in order to.
Well, I think there's
use cases that CAP 21 allows. Right?
There's two problems here. I think one is I think people are like massively mistaken about, you know, how hard it is to adapt to something where you have like multiple versions of the structure, right? And we already have an existence proof that we did it with something which was much harder, which was the accounts, in order to get the muxed accounts, right? So if we survive that, we can definitely survive this. The second thing is I think people don't appreciate how much should be automated, because currently in our SDK, we're doing too much sort of manual stuff, right? And if you use sort of like more meta programming friendly XDR libraries, like say, you know, Gokster, the one that I wrote, or the XDRPP that we're using for Stellar, you can actually automate a lot of this stuff. And so what would be great is that since there's like the places where people actually care about this, probably if they do it all, is when they're manipulating the JSON. And it's not, it would be easy to write just like a few simple rules to like make the JSON look the same, or to understand the JSON both ways. But, you know, whatever, I'm just beating a dead horse. Well, I'll just, you know, maybe a thing to do is like introduce a cap that's like a meta cap, but like this is how we should do upgrades, and show some evidence for why in the future it's better to actually version structures and put the versions at the top instead of putting these ext things at the bottom. But whatever.
So general preconditions, I think that's what was it Lee that was asking about that?
Yeah, so I
it's
think
not general. Like it's a misleading name.
Yeah, I'm not really too fussed on the name, but I'm just.
No, I'm not no, it's not the name, but the, you know, right now it's hard coded, not general. That's what I mean by it's a lie. So I thought it
so how about you want it to be called like precondition V1 or something? Like, what do you want it to be?
No, I would like make it an array of you know, static array or something.
But we've already let's not relitigate this.
I know
we already discussed this, and
only introduced because so actually I have a more of a question related to the CAP, because what I've been the time I spent actually in the past few days was looking at the CEP, that is the payment channel protocol, trying to see, okay, like how is that CEP related really to the CAP, and it doesn't look like the CEP is using all of the functionalities that are in the CAP. So that's kind of what, you know, where I'm coming from, is like I feel like it's trying to guess on use cases that maybe don't exist, and at the same time I would prefer to have something that's that can be extended easily, as opposed to right now it cannot be
because we can just version it, right?
No, if you version it, you break everybody.
Even if we're doing the fully nested, there's no reason why we can't version the V3 thing that's dangling off the V2, right?
No, but like if you want to add a new condition, you would break all consumers.
No, because you would just have a data structure that includes one.
Yeah, now you need to add the accessors for every single condition.
No, you just need a function that always converts to the latest version, but that can be done in an automated way.
Could we just add a V2? Can we just add an extension on the end of the general precondition so that we can V2 it, dangling?
I mean, we're gonna have to if this thing is, like we're totally bike shedding this thing. Like, and does someone else want to make a pass at this, and then like I'll clean up the mess so that like, because otherwise I'm gonna do something that like you guys aren't gonna like.
I think it's worth just responding to Nico what you said about the payment channel protocol doesn't use all of the fields. The only field it doesn't use right now is ledger bounds. It uses everything else. And I think that was a comment or something that David and I talked about very briefly, was it doesn't make sense to keep ledger bounds because of that.
Why? What is the argument for keeping the ledger bounds?
So the argument for keeping the ledger bounds is that the current payment channels are kind of probably safe enough, but they're not safe if there's like something happens and there's like an hour of downtime on the network or something, which does actually happen periodically. And so somebody who's paranoid and wants to create a payment channel that is actually robust to downtime of the network would also need the ledger bounds to be safe, right? Because the network goes down, all your timers expire. But if you have this ledger bound thing, then you have, since the network wasn't creating new ledgers while it was down, you still have some opportunity to, get in there and prevent someone from incorrectly closing the channel.
Personally, I'm like not really that concerned about changing the however we structure the preconditions. Like we could make it an array of whatever of unions, and that would be fine. Or we could make it it doesn't really matter honestly to me. I think like at the end of the day, like people are caring much more about writing these than reading them. Like the only thing that really should be reading these at the end of the day is if you for some reason want to inspect something to make sure that you're signing the thing that you mean to be signing, which I think is like a very, very, very small subset of the code, because a lot of times you're signing the transactions that you're creating yourself, in which case you kind of know what you're doing, and core. And since like this stuff is super isolated down to just like one code path in core, and if you read the wrong branch in your signing code, and then you're just not going to sign that transaction because you didn't know what it meant, or your code didn't understand it. So like, I don't feel like the risk of blowing yourself up with edge cases here is particularly high. So like, let's not fight about it that much. Like we have unions on all sorts of stuff everywhere. And we just kind of, transactions for example, I could send you a V0 transaction. If your code only knows how to handle V1 transactions, you're going to blow up. So like, we already have these problems.
John, is your comment about whether or not we need ledger bounds?
No. It's about like the whole, like Nico saying like these aren't really general. It's about that part. Personally, I think my point is kind of like the ledger bounds seem reasonable to me. The structure is reasonable to me. We could do a different structure and it would also be reasonable to me. I don't see a lot of reason to hash it out for 20 minutes.
Could we just change the name from general preconditions to something else?
Yeah, I mean, like if you named it like preconditions V1 or something, that would map up with the names that we normally use. Okay. But like
that sounds good.
Doesn't really matter to me, because if you didn't change it, I would just stick it, like if you called it general preconditions, I would just like, if I needed to change it later, I would just call it general preconditions V2 and call it a day. So,
Can we add an extension as well, so that we just follow the same dangling pattern?
I just don't see a lot of reason to, is kind of my point here. Like, if you can't handle the types of transactions you're trying to sign, you won't sign them. And like, great. If you didn't sign something, then you didn't agree to something you didn't understand. So
that's not actually.
The point is, it's already in a union. We've already got like no preconditions and time bounds, right? So there's like, if it turns out that we need a different kind of preconditions, we can just add a preconditions V2.
Nobody can handle the it's the extension 2, like number 2, like case number 2 right now anyway, without modifying their code. So like,
it's more about thinking about what happens when you make a v2 of that thing, right?
Yeah, that's what I'm saying though. Like, if let's say that like I add a new feature, which is like, I don't know, like time times ledger bound, some super crazy stupid condition that nobody needs.
How about number of ledgers that aren't completely full, or number of blocks?
Sure, that's actually plausible. Number of ledgers that aren't completely full. But like, if you want to sign this, you're only going to sign transaction. Like, if you want to sign stuff and you want to understand what you're signing, so you're checking for some condition, you're not going to sign stuff that you don't understand. So like, your code might barf, but like, you won't have signed something that you didn't understand. So it's fine. Like, I don't understand what the bad case, if you don't understand something, is. You're just not going to agree to something that, like,
I don't think there's a bad case there. I think the case that I'm concerned with is the same case that we were talking about with the account extensions, and that is that every SDK, every application that parses the XDR now needs to look for time, or now let's say ledger bound. So say ledger bound stays in the V1, then we add a V2. Ledger bounds is now going to be in 2 places, so it needs to look for it in both places. So there's the parsing case, and then there's also the creation case for the transaction. So SDKs need to make a decision about what's the general best practice for creating a transaction that has ledger bounds. Do they use the new V2 that has ledger bounds, or do they use the new V1, or do they only use the V2 when they're using one of the new fields? And for the most part, in a lot of cases that probably won't matter, but in the cases where somebody builds a transaction and then they want to build that exact same transaction and they want to expect the SDK to build it the same way, that does matter, because if an SDK developer decides they're just always going to use the latest version structure, then the transaction is going to change every time they build that same transaction. So we're actually, in some ways, we're actually introducing a backwards incompatibility, because we're saying, like, you conceptually build the same transaction, but SDKs may make it so that you're actually building a different transaction.
I see what you're getting at here, and like, that's a concern. I don't totally think that concern is necessarily exactly relevant here, in the sense that, like, I don't know what promises SDKs are making, but like, if an SDK is promising to have that property that we're not going to retroactively change your stuff, then that's really a property of the SDK. Because like, if you're creating like a semantic transaction, I feel like the SDK just has a promise to do what you asked it to do. But if you want to have a stronger constraint, like an exact transaction, you probably need a different vocabulary in the SDK for that. But yeah, putting that all aside, like, the thing that makes me scared about like doing the nesting in this context is, like, you really, really, really don't want to sign something that you don't understand. Like, imagine that you're a guy and you're like, I'm looking for this ledger bound structure, right? Which I know to be in the case 2 extension, also known as general preconditions. But like, imagine we're dangling a V3 off of it. You have to actually, like, you can't just call a function to look up the V2 one and look up the ledger numbers, because you actually have to check to make sure that the V3 stuff isn't there. Because if it is there in nested, you're going to sign something that you didn't mean to sign.
This is what I wrote in the code example in the agenda. This is why it kind of explodes and becomes pretty awful. Especially as versions increment, you're going to get more and more of these to go down the rabbit hole of checking.
So I really think, like, the much safer thing is to just fail to sign things you don't understand, and then update your code to understand them, instead of having to handle all these cases of like, oh, like, what I need something that's in the V4, but the V3 doesn't, like, but the V3 exists, but I don't care about anything there. And maybe the V5, like, that gets really confusing, and your code can change out from under you just as the extensions grow, basically.
And I think that there's another thing too, which is that if we were really trying to build this like little language of, like, have an array of little precondition operations that can be sort of like arbitrary, or can be constantly extended, honestly, we should try to unify that with like the claimable balances, right? Because we have like 2 different little languages for like preconditions, right? Or if we do have 2 different ones, then it just seems like really needlessly complex for people to like learn how to use this. So what we have is simple. It doesn't have to be the last word, because we can change it by again using these unions, and it covers like all the things that we need to do payment channels, plus the thing that we need if we wanted to do like super safe payment channels, which like there's, you know, some people like might want to be able, like people could potentially object that, you know, well, on Ethereum, I can make it safer by counting ledgers or something. That like, this is like a good set, and that we shouldn't let the perfect be the enemy of the good. We should just do this. And if it turns out that it's like so successful that we want like 12 different other slight variations on the preconditions, then we can do an array of programmable thing, or maybe we can update the claimable balances and have like a general language for describing preconditions.
I'm pretty in sync with David on this one personally. I think the argument is basically just a lot different than the ledger entry stuff where we already have something established that we're already doing. So.
So what would that mean the next step is for CAP 21? Like, what is the revision and who's sort of taking it on?
I think the only thing we said we might change is just change general precondition to precondition V1, and that was it.
That's it.
And we would keep ledger bounds.
Wait, I thought we had to move to the extensions, these like multiply nested extensions.
I think I thought what John and you were advocating for was no extensions.
I thought we were just talking about the preconditions, not the ledger entry extension. There's two questions, right? One is, should our preconditions be how to do future extensibility for the preconditions that are embedded in the transaction, and the other is what to do about the ledger entry extension part, or the count entry extension part, right? So, John, I believe you and I were talking about just what goes in an actual transaction, the preconditions, right?
Yeah, that's the thing that I think is really dangerous to have these accessor functions for, that just like that don't necessarily look all the way down to the bottom.
Right. And so of course, while I'm happy to leave CAP 21 as is, it sounded like we wanted, it sounded like everybody else wanted me to make like these, to dangle accounting extension V3 off of account extension V2.
Yes. Yeah. Sorry, I left that out of the list.
So I guess I can just do that. Fine.
Okay.
My stomach, but I'll do it.
And so after that change, we'll sort of reevaluate CAP 21. Are there any other questions that we want to talk about CAP 21 right now, or should we move on to CAP 40?
I did have one other question about this. There was like something that struck me as kind of strange. Yeah. So there actually, there were like 3 lines I pulled out, and like all of them were basically about the exact same thing. And I kept thinking that this was really weird. There's a sentence in the proposal that reads, all transactions are validated, sequence numbers increased, and fees deducted before any operations are executed. One consequence is that bump sequence operations, though they update an account seek time and seek ledger, do not affect the validity of other transactions in the same block. But that's actually not how things work at all right now. So this is like either a very profound change to the way that things work that we'd have to recognize is a really big change, even though I don't think people are using bump seek a lot, or it's a misunderstanding of the current situation.
Sorry, somehow the audio is breaking up. Sorry, what's the line number, or what can I search for? Because you broke up when you were saying which.
Yeah, let me just tell you what to search for. If you search for one consequence is, that'll probably work. Let me see if that works.
Okay, yeah.
Yeah.
I often find myself searching for one consequence is.
Right. But that actually is what happens currently, right? Bump sequence happens when you're executing operations. It doesn't happen when you're validating operations.
Correct. But like let's imagine that you have one source account, you submit transactions T1 and T2 at sequence numbers, n+1 and n+2. You get the point. And the behavior, like both of them are no ops. They contain like a bump seek 0. Sorry?
Yeah.
I don't know if David can hear me at all right now.
No, I can't. But okay. the thing of current.
But I can't hear David.
Is
you're breaking up, David.
And Oh crap. Usually I'm on summer when like I couldn't do this meeting, but I want to move forward. So you have that. Is actually. Can you hear me? All right, I'm going to mute my
Not
video.
really.
Maybe it will.
Oh, that's much better.
Maybe that will be better.
Yeah, now we can hear you.
Can you guys hear me now?
Yeah.
Oh,
Perhaps not.
Transaction 1 and transaction same block. Okay, where's the chat?
Let's take this one off. Let's take this one to the mailing list, I think.
Yeah, and I want to point something out that doesn't actually impact the behavior of the bump sequence. The payment channels are not actually dependent on that. So
I think that what that breaks is that it breaks that right now you can have transactions that fail later because of bad sequence number.
Exactly.
Like you can imagine.
Disabled?
No, David, you have to go on the mailing list at this point. You're banned from this call.
There's no chat, David. Not any chat that I see, at least. So
yeah, there's not a chat in this interface.
One does not simply chat during the protocol committee meeting.
Yeah, it sounds like he can hear it. So yeah, the concern is that you have two transactions. First transaction and sequence number, n plus 1, and then the first one does a bump sec to n plus 10. This invalidates the second one that will fail with a bad sequence number, but that will only happen at apply, like when you actually apply transactions. And the proposed change would actually break that. If you were changing, because it would allow both transactions to execute.
Exactly.
So if the second one has like some funny, side effects in the proposal, now those side effects can actually happen.
And there are like some pretty important consequences to another sentence in the proposal, which is that earlier in the proposal, there's two sentences that read, a transaction whose preconditions are not satisfied is invalid and must not execute even to fail, meaning it cannot change the source account sequence number or charge a fee. But basically the example we just gave, you could imagine a seek gap thing, min seek gap, min seek age, whatever, you guys know what I'm talking about. And that would be broken by the current bump seek semantics, because it would actually write it during the apply time, and then the later one would be invalid at apply time and therefore fail. So yeah, there's probably some like edge cases here that we have to iron out. Either we have to say that these work in a different way from other stuff, or yeah, I'm not super sure.
Or not allow, I thought what we talked about before was maybe not allowing more than one source, like that source account can only be in one transaction.
But that's not necessarily easy. Well,
I know it's not, but that's the only way you can make this work, I think. But maybe there's a better. That's I think the only way, but there might be another one that smarter people can figure out.
So it sounds like this is something that will bear further thought. Like it will require further thought to sort of figure out what's the best solution here. And so I think this is something that someone, maybe John, if you should raise on the mailing list.
Yeah, I'll send an email about it or something.
Call me by any chance. I don't. There. Phone in actually.
No, David, you have solar flares or something. Can't hear
you. Like I'm on a crappy Wi-Fi now, but like this is like super important. Or can we continue this meeting next week or something? I knew this was like a bad week for this. This was like the week that I wasn't going to have a wired internet.
David did predict that. It's true.
Did, yes. I apologize for trying to force it forward, but I mean, we can certainly.
This is super important. This is super important stuff that we're talking about now. So there's no way. Zoom usually allows you to like call and get in by phone, but when I click the thing, it doesn't give me a phone number.
The crazy thing is, I can hear everything you're saying now. So maybe just tell us what you want to say.
Okay, what I was going to say is, if you have transaction N, and you have transaction n plus 1, and n is a bump sequence to, like, say, n plus 2, both can currently execute.
Yes, they will both
Right?
execute, but the
No,
second will fail.
currently the second one fails, exactly.
How does it fail?
So
You
Because it's
actually
a bad
execute the
sequence
bump
number.
sequence when you're validating transactions?
We're
So
You get bump
enforcing.
sequence. Suppose transaction n, like, changes the signer or something, right? You're still charging a fee for transaction 2, right?
But it fails. Exactly. Yeah, it fails.
So what kind of ends up happening is, like, any check that we run during validity checking also gets run during transaction application. So basically, you get all your validity checks get done twice. Once kind of speculatively, and once for real.
And if it fails the validity check that it does again during application, it fails at application, it's on the ledger, it's charged a fee, and the sequence number is consumed?
Yeah.
Okay, so what about this? What about saying, like, these preconditions always get checked twice? If it passes the first time, you get charged the fee. If it passes the second time, you then can execute.
That's fine. That would basically map up what we're saying. But the question is, like, does that break your stuff?
No, I mean, it's a little more expensive, but it's like,
The age thing, that's what John was talking about, right?
Yeah, I don't know if you were able to hear me at that point, but, like, this potentially messes up the seek age or seek gap. I can't remember.
So maybe we check the age things only once in the other fields twice, and we, like, rearrange the data structure if it needs to be, such that it's very obvious which section is the stuff that gets checked once and which section gets checked twice.
In all honesty, like, there could be some sanity to basically saying, like, hey, like, these precondition things, we only need to check them once.
But you're saying that this would currently allow things to succeed where currently they fail.
Well, right now the preconditions aren't anything that can change state. Like, time is time. It's all checked against the close time, so it shouldn't matter. But
yeah, they can't. They can't. The thing is that right now we don't have a concept of checks that are done at apply time before, like while we do, like, the fee processing, for example. Like, we don't have that kind of concept, which is, I think, what we're talking about, like a phase that is like, let's do all those checks that are, like, on a, only done once per block before anything else happens.
that would actually be really easy to implement. Like, a bad
that would be easy, but that doesn't exist today, right?
Agreed. Yeah.
And I think I wonder if it would do something funny also in terms of, like, results.
Oh yeah, there'd probably be some annoying cases to handle there, but, like,
because we don't have a place right now to express that there would be a failure in that phase for like, for Horizon. I'm thinking, like, the meta doesn't let you fail early like that.
Hold on, wait. Do we really need
to?
No, like, early, like, it doesn't. There's, like, it apply at apply time you get the result, but you wouldn't know that it's a failure that happened because of an early check.
There's something kind of interesting going on here, though. Like, I guess the real point would be, like, these precondition checks are something that should be done at validation time, but not at apply time. Because if they succeeded at validation time,
I guess you're right. Yeah. That could also be the change, right? The new, like, the updated thing is that we have certain checks that are only done at validation time.
Yeah, I bet that could be useful for other reasons.
So I mean, the problem, the annoying thing is that, okay, well, one thing, I mean, it wouldn't be, I mean, like, arguably the behavior that I'm describing here is not, like, terrible. It's just, unfortunately, like, a slightly more permissive than what we currently do. It might not be inherently fatal.
So David, one of the things that's actually annoying to do those checks at validation time only is that we're supposed to have as an more or less as an invariant that those checks don't depend on ledger state. I mean, like they only depend on sequence number, I guess.
Right, but you're
And
still loading.
signers.
You're loading the account entry, right? So,
yeah, that's the only thing we load. But like, if we wanted to have like maybe other dependencies there, like in terms of checks, I guess you could.
I mean, everything
but
depends on either the ledger header or the ledger entry. There's nothing. You don't need to fetch any,
right.
trust lines or any other kind of state. So I think that we should still be okay in terms of no extra database accesses.
I don't think this is a big issue. I think this is something we can handle in a sane way. I think
Okay,
it's just something
I
that we
think
have to think about.
how about, let me
Is it-
just like address it. Like I can make a pass of this and I can propose something that is both compatible with what we're doing today and has kind of the least overhead, like avoids double checking if it's sane to do so. I have to think it through a little bit more, but I could have, something by next week, or next week I could do something, but.
I mean, that feels like the logical next step to CAP
Yeah.
21 to me. Yeah.
Okay, so I have to address this, and I have to address the nested ext structures.
And I think, yeah, like with this new condition, like one of the, I guess that paragraph or whatever section in the CAP will be where you can talk about if we have like specific rules around multiple transactions that maybe you want to where you want to allow, certain combinations. Like what I'm thinking here is that if you have 3 transactions with this min age requirement, I think only one of them can be valid. Because otherwise you're going to break the payment channel, the assumption that you have a grace period every time you process a transaction for the payment channel protocol.
That's a good point also.
Well, okay, I will.
So I think that's good. That's a good change. I think we're going to highlight this specific invariant that we're trying to go after here. That's the same invariant that we need for the transaction queue policy.
Exactly.
Okay, so I think I need, is there anything else? Because I want to make sure we discuss CAP 40.
No, I think we should move on to CAP 40. I mean, there's only 4 minutes left, so let's jump to CAP 40 because I feel like there's a clear path with CAP 21. CAP 40. What is the, let me see. So CAP 40, just trying to find myself. So for anyone who's watching, this proposal allows participants in a payment channel to safely exchange signatures for a set of up to 3 transactions in a single step. It looks like there are some open questions, several, but we don't have that much time. So what is the most important question that you need answered here?
Lee?
So I guess the question I'd be most interested in is Nico raised, is this the right structure? Are there other things like Merkle trees that we could be using?
And maybe I can add a little more detail on, I asked that on the mailing list, right? Like the question there is really, so I looked at, the proposal I think makes sense with the current proposal of payment channels because you only have like a very small set of participants. If you are looking at what you would need if you have more participants, or maybe it's like those multi-hop things or whatever, would that make this like insufficient? And then you need at that point like some way of expressing a bigger set, like a Merkle tree. Maybe, I don't know, something else.
I mean, I think that what we have now is so general, like, yes, you can't do Merkle trees, but you can like interoperate with like Ethereum or like other blockchains. Like it's, so not only does it like save entire round trips and like eliminate a whole bunch of foot guns on these payment channel protocols, but it also like in such a straightforward way adds support for essentially we can basically do HTLCs with other blockchains without even the hash part, right? Like you can literally like just kind of tie transactions together across blockchains. So from my point of view, this is just like completely obvious in retrospect, except, you know, obviously it's brilliant because like nobody thought of it until now. But like this, like it's just, it's so straightforwardly like exactly what you want in so many situations where it's like, I want this to execute only if this executes. Fine. If you execute this, then sign the other thing, right? And it's like, we're done, right? So it's so simple and so useful.
I also had like a very similar reaction to this when Lee suggested it. I was like, oh, that's very clever.
No, like no, I mean, I agree. Like, I think it makes total sense for what we're trying to do right now. It's more the question for me is that going to be durable in terms of design for the payment channel? Because I know for example in Lightning,
I think
they didn't go that
far
route because
beyond
they need
payment channels.
No, but like in the context of payment channels, they didn't do that with Lightning, for example, because they need a lot more to unlock a lot more transactions with one transaction.
No, I think honestly, I think they just didn't think of it, right? Because you could just, if you have a 3-hop like Lightning payment, you could just like have to sign, you know, all 3 hops in order to cash it in.
Yeah,
right?
yeah, but so you need 3. Yeah, you need, this transaction needs to have 3 additional payloads, right?
Sure.
So that's why this doesn't scale. That's the part where it doesn't scale. So that's my question.
Let me ask you a question, Nico. Like, sometimes there exists a world where it makes sense to have something that's like simple and easy to use, but not necessarily scalable, and something that's harder to use, but highly scalable. I feel like the Merkle tree falls into that category of like, it's obviously much more scalable, but it's also not as easy user-friendly and not as easy to fit into like the current Stellar model. So like, could there be a world where we
like
support
a Merkle
both of
tree
them?
a Merkle tree of one element is the same thing, right? That's kind of what, maybe, I don't know. That's it's more like if the design relies heavily on such a construct, I'm more questioning the design of the payment channel
But
itself.
honestly, you could do the Merkle tree. It's just the Merkle tree would have to be on the Ethereum side, right? But like, but you know, obviously we don't have like logic to interpret Merkle trees. But the point is like, because you're signing arbitrary data, right? You could do something such that like a single payment on Stellar, like a USDC payment on Stellar could like unlock like 20, you know, USDC payments on Ethereum, right? And do some kind of complicated multi-way exchange that way.
David, if we like, so your point is well taken that if the Merkle tree part was on the Ethereum side, perhaps this would work there. So is the argument you're making that the construct that Lee proposes is sufficient for the Merkle tree case, assuming that Stellar could also handle the Merkle trees? Or is the payload not big enough, or, you know, whatever?
I mean, you know, to be honest, the things that, the cases that I think come to mind involve multiple signers rather than signatures on multiple transactions, right? Because you could always on Stellar, we have a different way of unlocking transactions, which is like twiddle sequence numbers and use like and use preconditions. So so from my point of view, the real bottleneck here is that just like I don't want to add like a gazillion signatures just because verification is expensive, right? So if we somehow change the transaction fees to like also include the number of signature verifications or something, like I could see like there's a very obvious way to extend this to have like more than 1 or 2 signatures.
Well, actually, that's related to that question on number of signature verifications. Actually, that's sorry, I missed that as part of the CAP 21 conversation, because you guys added the extra signer at the same time than CAP 40, and I was not sure on which CAP was tracking what. One thing we could do, because in the context of CAP 40, it's just another signer. I mean, the extra signature, it doesn't matter actually, because it's being processed like any other signature, right?
But we don't charge for signatures, do we? I thought we just charge per operation.
So now going back though to CAP 21, how it's being used in a new way, right? That is, you can have like those, is it 2 or 3 additional signature checks? I would argue that those should be counted towards the 20 signatures limit that we have on a transaction.
Okay, that's fine.
Right? Because that way we don't have to change the model in terms of like fees or anything. Because right now it's, I mean,
Sure.
if we are going
Done.
with the, do you see what I mean? Like I think it gets too complicated.
Done.
Right? And that's a CAP 21 change, because CAP 40 just introduces the concept of this new type of signer.
I also want to say we're over time, so I think we're going to have to cut this. But I feel like with CAP 21, there's a clear path forward, and it's that David is going to make those 2 revisions. With CAP 40, is there an easy next step that we can take here just to keep this moving, keep pushing? Is there a discussion that we need to have either synchronously later or async on the Stellar Dev list about this question?
I think we should move to accept CAP 40 today.
Yeah, I feel like the argument about, you know, would it be better if it's a Merkle tree? This is a little bit like why not both? You know, this is very simple, and it's you know, only really useful in specific constrained cases, like the payload has to be below a certain size. That there's a lot of constraints, and so if the constraints are a match, this is a great use. And then if the constraints aren't, and we have use cases that are outside those constraints, then maybe we need some other type of signer, like a Merkle tree signer. And then, you know, with that signer comes a whole lot of costs and things we have to figure out, bigger problems to solve.
I mean, like the only reason I would say it should not be accepted yet is because we don't, like, it doesn't make sense to have CAP 40 in the abstract. It's actually in the context of CAP 21.
Actually, it does make sense in the abstract. The same way we have #signers. It's just like a better.
But like, there's no use case. Like, who is going to use that?
Anybody who wants to like tie multiple.
But who is this anybody? Like, my point is that caps, what we have in the, you know, in the description of a CAP is that you have to have the use case before we actually go and spend the work on implementing those things.
So you're advocating for holding off on accepting CAP 40 until.
Yeah, I mean, it looks fine, right? Like from what we're saying, it's fine. It's more of a, like, we're not going to spend time implementing it if you know, if we don't have the full story.
But so we could just make a soft sort of promise. Okay, we're planning to accept.
Yeah,
CAP
this
40.
one is like
right after we accept CAP 21, we'll
looking
do it.
good.
Okay.
We'll do a
So
batch
basically,
accept. Yeah.
So ideally, our next protocol meeting, whenever that is, we could accept both CAP 21. Which
exactly. Yeah, I'd
CAP
rather
40.
do that than try to do this piecemeal thing, because the point of all this is like to get something that makes sense for payment channels.
Yeah,
sure. But I do think CAP 40 is just, it's so simple and it has so many additional uses. It's just like a fantastic thing in and of itself. But
I would actually, one thing I would love to see in the CAP 40 proposal would be a use case for CAP 40 that doesn't depend on CAP 21. That would be cool. I would like that.
Lee, can you add like an Ethereum like swap?
Sure.
Okay, so that's all that CAP 40 will, that's like basically the requirement for CAP 40 is Lee's going to add a use case that doesn't require CAP 21, rely on CAP 21. The goal for next time is to review the changes that David makes to CAP 21, ideally to get CAP 21 shortly followed by CAP 40 accepted. Cool.
Cool.
I think anything else, we'll just look to the Stellar Dev mailing list. And everyone here, thank you so much for joining. Thanks for your time. Thanks for thinking this through. Anyone out there who's watching, thank you so much. You know, it's always great to have you here, and feel free to join that Stellar Dev mailing list if you want to see these discussions and participate in them yourselves. There's a link to it in the show description. All right, sorry we ran over everybody, but thanks again for your time. Bye.
Bye.